Guys, I'm super happy to seeing you here on the monthly webinar of mechanical intelligence powered by Leo AI. So for whom don't know, mechanical intelligence is the world's community for AI, for mechanical engineering and product design. We have a few thousand of members, more than 10,000 already, including email, newsletters, etc. People that are mechanical engineers, professionals, company leaders, industry leaders, CEOs, head of engineering that want to stay ahead, want to get the best tools and strategic tools to provide the best for their teams, and not necessarily only Leo AI, right? This is a safe place for mechanical engineers from around the world, as well as vendors that develop AI algorithms and tools to share what they can offer, the others to share what they want and need. And this is a safe place to share about everything new on AI for mechanical engineering, tricks, tips, tools, concerns, research, etc. So like every month, we have a very, very rich, agenda for you guys. So I will start from introducing myself, introducing Leo AI and what we can offer. And here we see Professor Faez Ahmed from MIT joining. Hey, Professor Ahmed.
Hi, Maor. Good to see you.
The pleasure is all mine. So I see that you are joining from MIT from course 2, right? From the Department of Mechanical Engineering. I can recognize.
Yes.
Wonderful. Yeah. So my office was just, not very far from there. So happy. I feel at home when I'm seeing this, your office.
That's great.
Thank you so much for joining. Professor Ahmed is going to share his groundbreaking research on the DeCoDe lab at MIT. This is one of the world's leading groups that develop AI algorithms for CAD and for mechanical engineering. We'll talk about the relationship between CAD and engineering. It's not the same. We have very strong opinion about this. Also, we'll talk with JJ Schwartz. JJ is one of the Leo AI customers and users with 20 years of experience in the mechanical engineering industry, specifically in aerospace and defense. And he's going to share about how he's using AI and Leo to develop better, faster, but with confidence. And of course, security and everything. My goal for today is to share with you guys everything new about AI, but in a professional and I would say cautious way. Right? This is for the better and the worse. Everyone talks about AI right now. And when everyone talks about AI, it feels that there is a lot of hype and a lot of, BS, but there is a core of truth. And our goal here is to talk with the world's leading thought leaders to cover, this truth in all this world of noise and buzz. And specifically for us mechanical engineers and people that develop physical products. So I will share a little bit about myself. My name is Maor Farid. I'm the co-founder and CEO at Leo AI and the co-founder of the MI community, the mechanical intelligence community. In my background, I dreamt to become a mechanical engineer like many of you. Hey, JJ, what's up?
I'm great. How are you? Looking forward.
Fantastic. Looking forward to talking to you. So like many of you, I dreamt to become a mechanical engineer. At the first time that I saw SolidWorks, right, it made me envision how my future is going to look like, how I'm going to do my impact by building the next generation of robots and medical devices. So I completed my bachelor's, master's, and PhD, all in mechanical engineering. I was fired up to start. And then I started to work as a mechanical engineer. And I realized that I maybe have done the worst mistake of my life, because I remember that it was exactly the opposite of what I envisioned. It was not innovative, not creative. I was spending months just to find a bolt and a ball bearing in hard copy books in German, and I don't speak even German, and online in our PLM. So I pivoted my career into AI after a few years. I was developing AI algorithms for defense purposes. And then using Fulbright scholarship, I went to MIT for my postdoc. It was in the Department of Mechanical Engineering. And we studied the intersection between AI and mechanical engineering. And then it was the time to partner with my best friend and the most brilliant person that I know, Moti Moravia, to start Leo AI, to solve the problems that we experience in first hand as mechanical engineers. And I would love to share with you how we're doing so. In the meantime, I encourage you guys to ask questions here. By the way, I see the number of people here growing from second to second. So welcome, everyone. Please feel free to write questions here on the chat, right? If you have questions about what you're hearing right now, about Leo, about AI, share a little bit about yourself. I'm going to tell you not a few, like a lot of business opportunities started here. Like we have here head of AI innovation, head of engineering, and also junior engineers. Those are looking for talents. Those are looking for jobs or looking for tools, whatever. Share a little bit about yourself, what you would like to learn here. And you see, take the liberty to talk with each other, right? And create relationship here, right? And also, if you have questions to us, our team Leo AI is here to answer your question. Moti Moravia specifically, my beloved partner, and Eitan Steinberg, our beloved and incredible product manager and mechanical engineer. So, yeah, without further ado, I will start by sharing a little bit about Leo AI and what we're doing. So, can you see my screen? I think so, yeah, right? Fantastic. So at Leo AI, as you understand, we are mechanical engineers and AI researchers. Our goal is not to do an, sorry for my language, sexy looking Jarvis like Iron Man like AI. We are focused on real ROI use cases for engineers. In other terms, one of our investors is the co-founder of SolidWorks and Onshape. And he told us before he invested, he said, I love the fact that we are doing the most boring use case for AI possible for mechanical engineers. Because we believe, right? Forget about the technology. We believe that us mechanical engineers, human mechanical engineers, we should focus, even 50 years from now, when AI is going to be even bigger. We believe that mechanical engineers should do the cool 20% of engineering, which is lead the innovative process, lead the creative process. But all the tedious work of finding parts, answering technical questions, writing documents, making order on the huge databases that we have on the PLM, all of this should be offloaded to AI. And this is what we do. Engineering grade AI, which was built for leading engineering firms, obsessed on providing real competitive advantage. So we're going to talk about the problem, what is really broken in mechanical engineering right now, and then we'll show you the solution. So what's really broken, right? Before we started Leo, we surveyed and interviewed more than 900 mechanical engineers from around the world, from Sweden, from the US, from Asia, and we asked them, what are your problems? And we itemized the most time-consuming tasks that are facing today and their most bleeding problems. And we realized that even though they said a lot of things like SolidWorks crashes, or it's very hard for me to write documents, or to do extrude boss takes a lot of time and surfaces, we dug really, really deep and we understood that for mechanical engineering, the problem is not SolidWorks. The problem is not PLM. Those are the symptoms. The real problem, as far as we, understood, is that for us mechanical engineers, engineering knowledge is still siloed. Some of you are working in companies that have mountains of data, huge amounts of knowledge that exists 20 years, 30 years, 100 years if you are Scania, right? 130 years. Just imagine how many documents you have, right? Textual documents, PDF files, guidelines, etc. And how many CAD data you have. And there is a lot of information there, right? For example, if you're designing trucks, you want to understand what's the minimal thickness of the body of the chassis. It's not written in text anywhere. It's embedded in the CAD. You need to open SolidWorks or Onshape to measure it. So there is a lot of information buried in your PLM data, in your text documents, in your CAD documents, and also in the brains of the later career engineers, and you know them, right? The Joe at the end of the corridor, that only he knows how to choose bolts here. And last but not least, it's locked in the external knowledge bases. I mean, in the Bibles of mechanical engineering, the Shigleys, the Incomperas, right? The ISO standards, the MIL standard, the DIN standards. And it's very hard to get them. Google doesn't really know all of them. And if you want to get it from there, it basically will take you a few pages on Google. ChatGPT is even worse, right? But let's put it aside, I will talk about it. Sometimes those sources cost a lot of money, right? And you had this experience, I guess. When you find the article that you want, it costs $1,000 just to open it in Elsevier or Nature or Science. What's the problem with ChatGPT? Well, ChatGPT was not made for mechanical engineers. And what does it really mean? First of all, it cannot understand CAD. Why? Because it's a language model, right? ChatGPT, Claude, Gemini are called large language models. And as such, they're very good in understanding language, text, right? But us engineers, we live in the physical, geometrical universe. So for us, if you understand only text, if you read all the books in our industry and all our documents in our organization, and you cannot understand CAD, you're like a blind engineer, right? Imagine that you have a super smart engineer from MIT or whatever that read all your documents, but when you're asking him or her, hey, Joe, what's the minimal thickness of the chassis of the Scania 2024 model that we designed last year? He's going to tell you, I don't know, it's not written anywhere. I need to open CAD and I don't know how to read CAD. So ChatGPT and others are dead on arrival, are not made for engineers. Other thing, it's not connected into your PLM, so it doesn't understand your context. And as you know, if you are an engineer working for NASA, and I'm an engineer working for HP, both of us are asking for a ball bearing. I expect to get a mechanical standard SKF kind of ball bearing. You expect to get a titanium space grade piece of gear. Everything is about the context. So similar request, different result, different expected results. But the main problem with ChatGPT, and again, it's because it was not designed for engineering, is where he drinks the information from. ChatGPT is being fed by sources from the internet. And as you can see, the leading source is Reddit. Reddit is a network of anonymous people that share information, not necessarily true. And when you're asking ChatGPT, hey, how many bolts do I need for sealing this pressure cell? He's going to tell you an answer which was based on a Reddit post written by an anonymous people that is not necessarily a mechanical engineer. And just think how devastating the result could be, right? So what really is the problem? Because knowledge is very problematic to get all the information, the result is that you, mechanical engineers, super talented, and you as an engineering leaders, your engineering team is busy, I mean, spending something like about roughly 75% of the time, not in inventing or developing new stuff, but it's to reinvent the wheel. I mean, for example, here, this is a video of a mechanical engineer. We've done this real exercise. We told them, hey man, you're designing a suspension system for your system. Never mind what system it is. And for this case, he needed to add a spring. We made sure that he has a spring in his PLM. So the best case scenario that he's gonna find the spring and just put it in his design. Eventually, he was not able to find the spring, so he needed to design a spring from scratch. It took him a week, but it could take literally an hour. So he lost time. Then he spent a lot of money to bring this, to go to manufacturing and get it back and do, the testing, validation. And it's not vetted part, so he cannot really trust the part that it's validated and good to go. He had more ECOs to do because of the design was new. So if you had an AI, right, that is basically was trained only on the Bibles of engineering, more than 1 million Bibles of engineering, and understand CAD, right, that it can be connected into your PLM on an organizational basis, and then can answer your technical questions, find you information from your sources, and find you parts and previous designs that you've done, you're good. And this is what Leo does, right? We build the first AI that can understand CAD, right? And be integrated into your PLM and can answer technical questions, and every time to show you a source that it was based on. So we reduce significantly hallucinations or mistakes by AI because Leo was trained to tell you only the truth, right? Only the result that was backed by sources and to provide you with the best fit parts. So what we were able to show already, reduction of the reinventing the wheel. I mean, redesigning things unnecessarily in about a third, reduction of design errors in about a third, and time save of 5 hours a week per engineer, right? And those are averages. Like you hear from JJ, it could be significantly higher. This is the technology behind the scenes. So we, poached the best AI researchers. I mean, world class. I cannot say that they're the best because I'm super biased. I really think that they are, but I'm biased. So, and we developed the LMM, large mechanical model that can understand CAD, right? Those are our patents. So how it really looks like. So imagine that you are designing the suspension system, and now you have to add a bushing, right? So instead of going through all the process that I mentioned before, finding the sources, blah, 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 Leo understands the context, understands your best practices, and finds you bushings from your organizational database, I mean, from your PLM or Windows directories, and also from vendors. And you can configure the parts and just push them into your design. And as you can see, they're a good fit. We provide integrations to various CAD and PLM systems. If you have questions, we'd love to answer on a call. So basically, also Leo is doing calculations for you. So here you have a bushing, and we need to calculate what's the force that you need to shove it into the hole. So you don't need to run Excel spreadsheets anymore and find sources and plug it in. You just tell it to Leo. Leo understands the context. He writes the code for you, and it shows you sources, and this is the most important, sources either from your knowledge bases or from the Bibles that supports his response. And when you click on them, it opens up the right page in the right book, saving you the scrolling time. So it could be from Shigley, but also from your, the documents that you wrote 30 years ago. And of course, it runs all the calculation for you, runs the formulas, etc. The last thing that I want to share with you is our new feature that is basically in the hands of mechanical engineers around the world. And this is the groundbreaking technology, basically. It's called the Assembly Inspector. So imagine that you finished your design, and before going to manufacturing or to your supervisor, you just click on Leo Inspect. And it runs on all of your parts tree. And it tells you, oh, those parts, those in red, there are better options that are cheaper, more durable, or even more common, more standardized in your company. And just you can click on them, right? Then Leo can suggest alternatives. And you can see in one place the geometrical match to your needs and also how common those alternatives are. For example, if you will take this spring, it's very standard, it's very identical to what you already designed, but it's very common in your previous design. So it's vetted and validated. So after a few clicks, you can learn the information about it. You can replace it, right? And as simple as that, basically you're good to go. You went through all your design, and now you're in much better shape before you go to manufacturing, right? So let's see, one click, and you replace. And of course, you can share it inside your team, right? So this was the recent advances about Leo. And again, were used by thousands of leading engineering around the world, engineering companies. Now we are, Chevy, in your permission, Chevy will send you here a survey. You're going to have a survey in front of you. And I would love to hear from you what capability of Leo you liked most, which basically allows us to learn what you need, what you want, what you dislike, what you like better or less. So please answer the survey. It's super easy. You just click on the option that you liked most. And right here on the chat, even in text, describe why you liked or disliked what you saw. So yeah, this was about Leo. And of course, we would love to answer any of your questions. I'm writing here again two links. The first one is a link to our community. The second one is a link to book a demo meeting one-on-one with our team, right? Fantastic. So in the meantime, while you're doing so, I'm super happy to, invite JJ.
And it's a pleasure to be here. I want to. I already sent a message earlier to the group chat, and I'm going to send it again. Where I wanted to try something a little bit different to make it a little bit more interactive. I'm a Leo enthusiast. Also, I'm a big fan of working with Onshape for this reason, that you can just share an assembly.
Sure. So JJ, I'm sorry for interrupting you. Maybe you would like to start a little bit about your background, or I could share if you'd like.
Okay, well,
Maybe
I'll quickly introduce myself. Sorry, we
go
take
ahead,
it for
man.
granted
Sure.
when we're, because I see you that everybody knows, but it's Schrift. There's
Absolutely.
hundreds of people
We feel
around
at
the world.
home.
So my name is JJ Schwartz. I'm a mechanical systems engineer. I have 20 years of experience. I've worked on projects in aerospace and a lot in space. I've been involved with satellites, moon missions. And one of the last projects was developing, for example, oxygen plant on the moon concept. And so I'm here to share some of my insights. That's throughout those projects. That's how I got to know Leo, like many of you. And I enjoy sharing insights in general and specifically with Leo in this forum. So that's what brings me here today. Yeah, I won't, without any further ado, I'll start sharing my screen and start talking about it. And at home, like I said, I shared the link. You just have to click on the link. And the nice thing is the model will show up. And let me just share my screen and I will show you. So now everybody sees my screen. You see Leo and the model. If you opened up the model at home, you would see something like this. I might encourage you to close those notes here, and then you could see the model, and it's a parametric model that you could switch between the half-inch version and the quarter-inch version. And the reason I show this, I'm almost starting with the end. The subject here is design changes. We always have design changes. Every good design process will have that. And we have to deal with it. And it takes time to deal with those changes that come up. So I just wanted to talk about a simple design change. I originally designed this constant pressure tank with quarter-inch tubing that we can see over here. And then one day after a team meeting, we decided that we needed to switch it to a half-inch. Not to switch it, but to also have a version that would be a half-inch, which is just easy. And like most of the non-engineers in the meeting, they imagined that with the click of a button, like you see here, it switches into a half-inch tubing. But we all know that's not the case. The first thing that goes through our mind is, how am I going to start looking for all these components? And now I have to change everything, even though it's just a minor change from a quarter-inch to a half-inch. So what I would like to do also, I would have loved to do it live, but these things tend to crash when you do it live. So I filmed the whole process so that it would go nice and smooth. And as you can see here, we have the model. I start from the end here in the little clip I made showing the changes and how I used Leo to do it. Now I go through, these are all the components that are going to need to be updated on top of the tubing, but that's a different challenge. And then I'm going to go ahead and one by one, quickly, turn to Leo and see. My goal here also is to find the components in my local library. Okay, so a little background here. I'm working in an organization where I know that we have a large library, but I don't necessarily know what's there. So here you see the first. I'll just pause it for a moment. Right away, this component here, I was looking for, just like the prompt said, in plain language, help me find the Union T quarter-inch. And right here, it found the different components that I was looking for. Now I want to move ahead. Sorry. Okay, and I'm asking him to help find a quarter-inch Union Cross, and it finds all the different components and their location. Okay. And then I move along to the next one. I have this poppet check valve that's rated 1 PSIG, and I'm looking for the half-inch one. Okay. And once again here, Leo finds it in my local library, the component that I'm looking for. And I open it in the folder, and you can see it brings it to the library of all the components. And then I'm easily able to upload these components into my assembly. So the point I'm trying to make here is that we've all run into these design changes, and these aren't the most difficult things in the world, but we waste a lot of time dealing with these issues, whether it's dealing with internal catalogs that don't point you in the right direction, or if we're just not finding the parts because you don't know where your colleagues would have saved all of these components. So this is just a good example how any synchronized folder that you'll have put into your organized database, or if you'll synchronize, like Maor mentioned before, if the organization's, your company's PLM will be synchronized. So it's going to find that, and you don't need to be an expert in knowing where to look in your PLM or in the PDM. Or I know that one of the challenges I would always run into is finding it, writing it, doing on a text-based search, and you missed one letter or there's a typo and you don't find those components. So this is just a great example of how I was able to save the time. And very quickly, I was able to find the components. And here we're towards the end where I take the components, import them into Onshape. And that's how we get this final click of a button where, okay, you know, we want to make the design change. And with the click of a button, here it is. We're at a half-inch. So you know, I hope I wasn't too quick on the explanation, but just a quick behind the scenes search of how, in this case, I might estimate the design change instead of taking a whole day of searching for components and possibly looking from external suppliers. I was able to do this in under a half an hour and find all the components internally. So it also saved me the headache of, you know, bringing in new components from outside and setting up new catalog numbers. So that's the basic case. Here, I see there's some questions about Onshape if it's connecting to the Onshape cloud, and I know that's under development because I've heard rumors about that, the Onshape plugin, and I'm also waiting for that. Maor, is there anything you could share with us? Any insider?
Yeah, absolutely. Sure. So we launched our integration to Onshape, the partnership to Onshape, about 2 months ago, and we're working, you know, days and nights to complete the integration, and it's going to be ready in the next few weeks. For more detailed answer, Moti and Eitan here are replying, so they know the roadmap of the integration much better than I do. So Moti and Eitan, please write on the chat, and then we get something more punctual. Go ahead, JJ, sorry.
Yeah, so I was gonna, if there's any questions about the local library synchronization, how it helps you work faster, I'd love to elaborate. And also, like I said here, I wanted to share the model. I think I'm hoping, I can't really see the feedback, but I'm hoping it was able to help you follow just by switching. I'll also show you down below here, for those of you who aren't familiar with Onshape, you could play around with the model, do your section view, and also you have access to the BOM. You should be able to see the BOM, and then you could see how the components update. I was able to find the different components, and you can see how the BOM updates also in real time once the components change. Yeah, but that's it. The main point here is just how Leo helps solve a seemingly small, simple problem. Here, in this case, the design change. But because it's, you know, in this case, it's actually a relatively small assembly. We're only talking about 8 or 9 components that needed to be changes. But sometimes, you know, we're talking about hundreds of components that need to be changed. And that time really compounds. You know, it's instead of one day, you're talking about a week of work, and now you could finish it within 30, 40, 50 minutes, you know, depending on how many components we're talking about.
JJ, thank you so much for sharing. And Can I embarrass you for a second? Only if
Absolutely.
it's fine with you. Okay, but I owe you big time for embarrassing you. Just to be super honest, you know, a few years ago when Moti and I, when we started Leo AI, we were mechanical engineers ourselves, and we just wanted to help other, brothers and sisters, mechanical engineers, and to see Leo in the hands of leading engineers from around the world, and among them JJ, which is super humble. He has 20 years of experience in the aerospace and defense industry, literally designing stuff that landed on the moon that he designed using Leo, which is it's mind-boggling. So I feel like we are part of something very big. Just thanks to your feedback, JJ. Thank you so much.
With pleasure. And like I always like to say, I appreciate people who make these great tools, whether it's Onshape and Leo, because as engineers, we like to feel like we have superpowers, and this is the secret sauce behind our superpowers, these tools that make us run so quick. So thank you. Thank you, everybody.
Thank
I
you
hope
so
you enjoyed
much.
it. And yeah, I enjoy sharing the insights.
And now I'm very, very happy and honored to welcome Professor Faez Ahmed from MIT, one of the world's leading researchers, the intersection between AI and mechanical engineering. At MIT, Professor Ahmed leads the DeCoDe lab, where his team develops algorithms, specifically AI algorithms, that can actually design mechanical systems, right? Tools that generate innovative, high-performance solutions while balancing strength, cost, and manufacturability, which is super important for all of us. He's already working with organizations like Toyota Research Institute and IBM, pushing the boundaries of how AI can transform the way we design and learn engineering. Professor Ahmed, it's a pleasure and honor to have you with us. Thank you so much for joining.
Thank you. Thank you for the invitation, Maor. Really nice, nice being here, and great to see the community.
Absolutely. Thank you for sharing with us your time, Professor Ahmed. So you're leading the DeCoDe lab at MIT, which is one of the most exciting research groups, and I'm super biased, but super honest, one of the most exciting groups in the world right now that does real AI for real use cases. So I'd love to start with you sharing the work that your amazing group is doing in the CAD and AI space.
Sounds great. Yeah. So I lead the DeCoDe lab, which works at the intersection of AI and design. And I want to just start with the basic idea of when we think about design, we are all surrounded by all sorts of designs, whether you are using your phone, you are taking a flight, you are driving in cars, and so on. And we are surrounded by these products that have been created by engineers. And when we think about the process of creating the product, just like if we look at the car industry, this middle part they call the devil's cycle of going from a concept to market. It takes about 3 to 5 years. And this period of how much time it takes to design the product hasn't changed in almost last 20 years. I have kind of reports seeing in 2006, they were talking about we should really reduce the cycle time. And in 2025 summer, we had CEOs of large automotive organizations talking how it can save billions of dollars if we can reduce the time. And that requires, of course, the CAD part, it is the simulations part, it is the conceptual design part, as well as the prototyping and analysis. And because this process is so complex, people don't explore a lot. They think they would often take last year's product and make incremental changes. So there is effect on innovation. So with that, my group works at the intersection of AI and design. We are a group of about 20 people thinking broadly in this space. And the big question that we ask is, how can AI enable humans to create better designs faster? And for that, I think there is the fact is that if you think about AI and design, they're both very broad topics. So we did a survey where we started thinking of what are the key challenges. And there are challenges around adoption and deployment of AI. And there are challenges which are more fundamental scientific challenges, like maybe the spatial understanding of foundation models is a scientific challenge, versus there are cases where people have just not implemented, say, PLM integration and so on. There's also challenges around the design depth, which is for a very, very specific task, can AI do this? Versus design breadth, which is you have all these interoperables, you have all these different systems, CAD, CAE, and so on. and how can you actually bridge that gap across the design process. And across all of these four, we think a lot around data and infrastructure, model capabilities. Of course, this is where a lot of our research is, but also workforce and trust and compliance are big issues that we don't necessarily work on, but I believe is very important to think about. So with that, I'll just give you a quick overview of what my group has been looking at. We've been looking a lot at the biggest bottleneck of AI for design, and to a large extent, that is data. So modern AI is sitting in this corner. We are lucky if we get like thousands or tens of thousands of designs. And my group has created large data sets, including like car simulations to aircraft with Lincoln Labs, to mechanical systems and so on. And just to give you, like, assuming we have the data, there are different research directions. So I'll give you a kind of an overview of some CAD-related research. So we have been looking at this idea of large diffusion models that can map different modalities of CAD. Because when we talk about CAD, it is more of a representation issue. How can you represent your design? Do you represent it as a feature tree? Do you represent it as a point cloud? Do you represent it as a mesh? Do you represent it as an image? Or is just a text description sufficient? So what we have done is we have learned to map these into some unified representation spaces. And once you can do that, you can actually just learn how to create the feature tree or create the steps of construction of this model given some image or a point cloud, like here my student is scanning. We have also been looking at it from a large language model perspective. Given this image, can you actually create the code that can be used to create this? And finally, the latest work, which I find quite fascinating, is that we said maybe we can skip all of these and directly teach a model to use the software. So here you are seeing Onshape. And in this case, what the AI model is doing is given an image, it goes ahead and clicks the button to create this model itself. So this is like just an example how we did it. We created a huge data set of about 41,000 CAD construction videos. So once we created this large data set of creating these models and like basically looking at each time step, how the model was created, we trained, we recorded all of this, like when did you click the mouse, what did you do exactly, and so on. And after creating that, we basically looked at different geometries and learned from them. And we came up with a new transformer-based model which learns from videos instead of images, and it can learn from a given image. And basically what it does is it can, given an image, it can create your entire CAD model by using your CAD software directly. So it moves your mouse around. And the good thing about this is that you can take over at any point. So you can basically, like the model is moving your mouse literally on your desktop, and you can basically switch at any point and start using it yourself. So because this is using your standard CAD software. Yeah, and again, this can also autocomplete. So if you have an intermediate step, it can autocomplete. So if this is a target image, it can autocomplete the CAD model. And this is just one of the many research directions that we are thinking about. We have also been looking at like generally CAD copilots. So maybe going from requirements to design, and this is work with Toyota Research, where we are given some requirements of exact parametric dimensions and engineering performance coming from high fidelity simulations. Can you create many options that meet the requirements? So in this case, this is just a quick demo where a person enters in some CAD parameters, and maybe they'll not enter everything about a car. They'll just decide 10 things that they care about, and then ask our diffusion model to actually generate 3D geometries within seconds, and it would come up with models that meet that performance requirement as well as dimensional requirements. We've also been looking at agentic models, which is like you have models which are doing CAD, you have styling agent models which can do meshing, as well as simulation, and they all talk to each other using foundation models as well as geometric learning models and your engineering tools. So this is just a quick demo where one of my students is talking to the model, and they are basically first saying create a stylistic version, which is where it comes up with some stylistic versions. But then they are asking the model to actually go ahead and open certain softwares and look at the 3D geometry as well as the aerodynamic performance and so on. And at the back end, this is basically one of your large language models, which is doing the orchestration, and then there are individual deep tools that we have created to show that this is possible as an early stage product. All right, so with that, I can wrap up. I think broadly, my group works around a lot of topics from structural topology optimization to CAD to simulations, and I'm happy to take questions as we go. Thank you.
Professor Ahmed, it was, saying inspiring is an understatement. Thank you so much. So basically, you like one model. Forgive me if I don't get it. By the way, like guys I'm not sure that you saw a lot of hearts and applause here on the emojis. So I'm happy to see this. By the way, they didn't give me any hearts, so it's a problem, guys. You can do better. You can do better. So yeah, so you have one model that basically augments. Thank you for the heart. That augments the mouse or the cursor. I'm sorry, motion in order to build the BRAP model inside the CAD, right? It's like agentic,
So
really agentic for CAD.
It's literally doing what a human would do. It would go ahead and create a sketch. It would go ahead and click on the extrude button. It would click on the arc button. So it's using your CAD software like a human would do by clicking mouse buttons around the software.
Got it. So if the output of the model is cursor trajectories, why this is favorable over just generating the contours and I mean the features, right? Like why not generating the features? Why you found it more robust maybe?
They are different goals in some sense, because in one case, so the first work I showed was doing directly creating the feature, like it was creating the step by step how you would create it. And in that case, you can take and give it to a script. You can write a feature script of whichever is your favorite language, and that can generate the model. But in the video CAD work, what it's showing is one of the large data sets of engineering CAD is YouTube. So if we can teach AI models to learn from videos, the good thing is that the human workflow is very similar because it is literally going around and clicking on your mouse, and you can take over at any point. So if it makes a mistake, you can literally move your mouse and say, okay, let me actually take over, right? And this, from a learning perspective, is a very hard task because you have this CAD UI, which has, I didn't show this, but it's in the paper, where we said like most learning from videos is restricted to a few time steps, but CAD has so many options that you can click on. And it has to be precise because it cannot just click in that area. It has to like literally click on that point to select that point, right? So from a learning perspective, this is a very hard task. And what we are trying to do is create methods which can actually solve this problem.
Wow. So this is I've never imagined this kind of approach. So it's super fascinating. And you found this data from YouTube, right? I'm not sure what's the data size, but you found that this is less noisy. Like I was afraid a little bit for people's hand motion is a little bit noisy. There are mistakes. So of course, in every data set there is a measure of mistake.
Yeah, so the eventual goal is that it will learn from YouTube, but right now we actually created our own data set. So we controlled everything. We wrote bots which could actually create the data set itself. And we added
synthetic data.
Yeah, it's synthetic data. It's completely synthetic data. But to mimic humans, we actually added some kind of jitter. We also added like when a small part, we would zoom in because a human would not like, I mean, if it's something very small, you would normally zoom in and so on. So we added those rule-based systems to create our synthetic data.
Got it. Wow, this is genius. And, Professor Ahmed, you see a lot of tools. You are leading some of the innovation. You are in the frontier. So a lot of us here are junior mechanical engineers, some more experienced, and we all, for our reasons, want to really know how the next 10 years are going to look like. How do you see that mechanical engineering in our profession is going to change? In other terms, how mechanical engineers, how our profession is going to look like in a decade from now?
Yeah, so I mean, no one has a crystal ball, and I think a lot of times the predictions are difficult to make. But I do want to for us to take a step back and think from a data-driven perspective. If you look at how AI is progressing, the complexity of the task, if you measure it by the length of certain metrics, that is doubling every 7 months. we are also seeing that there has been almost a 99% reduction in per token cost of these models and using these models. And if you look at the projections of how many GPUs that are going to be there in 2035, that is going to be orders of magnitude more than what is there in the US right now. So with all these things coming together, I can completely imagine that this will have a huge impact on the engineering world. And the question is, mechanical engineering is a very broad field. I mean, it might have a lot more impact on some areas and a lot less impact on other areas, but it will look different. I mean, that is for sure. One of the things that I do think a lot about is as these generative models become better at generation, humans' job will shift a bit from not being generator of ideas to being constraint providers. Like we are basically we are, I mean, prompting is just one way of providing constraints or requirements. But how do you actually take a real world problem and provide the constraints and your requirements well and work with the AI, while AI is really good at generating a lot of stuff. And then the second part is verification and validation. How can you actually verify and validate? And those two roles might actually become more prominent.
Got it.
Now, 10
Got it.
years
So,
from now might be actually very different. I think this is more on the short term, 2 to 5 years.
got it. Okay, so 2 to 5 years. So you see the main adoption, if I understand correctly, in the creative process, or maybe the rendering of concepts. This is the first 5% of our work, but also in the validation, which is maybe the later parts, right? Because AI is very good, like, I mean, learning models are very good in interpolation rather than extrapolation. And our designers, mechanical engineers, by definition, should respect previous designs to be similar in some sense on how they respect boundary conditions, constraints, etc. So this is understood it correctly?
Yeah, so it could be in the early stages, but I was generally talking about content creation. So right now, these models are very good at text and image content. And in the future, it is a possibility that it will be much more better at structured data content. So structured data, we are already seeing with tabular data, with banks and everything. There is huge leaps that have happened in the last 2 years, which seemed impossible. CAD is another structured data, right? Simulations is another structured data. So assuming that, I mean, there is a lot of research and a lot of deployment that needs to be done to get there. But let's say that happens. Let's say these tools become very good at actually generation. So at that point, our roles will evolve into like, how do you actually set the requirements? How do you verify and validate? When generation is cheap, you can get 1,000 samples instantaneously. Now, how do you know which one is good or which one is useful?
Yeah, absolutely. So, we have what you just shared is basically AI breaking the Moore's law, right? Of doubling the capabilities every 2 years. You're saying now it's 7 months, which is insane. But this is the thrust, I'm sorry. But there is a drag force as well. And I'm talking about, mechanical engineering by definition is very rooted in tradition, right? Like it was an art going from father to son for thousands of years. Now it's coming from Shigley, right? From the fathers to us engineers. So what would you recommend to the engineering leaders? I mean, the VP of engineering, the CEOs, right? The decision makers that are saying, maybe AI is too early. Maybe I should not go on this train right now. What would you recommend them about leveraging AI today?
Yeah, so it's a tricky problem because I think whenever something becomes hyped up, you see there is two tail ends, which is there are some people who would claim that AI can do everything, which is by far not the case, especially for engineering. I don't think right now the proficiency of AI is there yet for most tasks, right? And adoption is also very low. On the other end, there is a set of people who would say, oh, this tool is not going to, it's kind of like when ChatGPT came out the first few months, and people were like, oh, it cannot do internet search. This is never going to be useful. Its knowledge is static. It cannot do 2 + 2, and so on. And the point that they're kind of missing is that this is just another tool. And as engineers, we have created many tools. And whenever a tool comes out, when finite element came out, there was a lot of opposition of this will never replace hand calculations and like the theory and so on. But eventually, as the tool, if there are enough good people working on a certain topic, this tool is likely to improve and become more robust and more reliable. And with that, trust will come, right? And the capability front will also increase. So I do think that it will be a change for pretty much every engineering task that we do. How much and how fast it will be, that really depends on a lot of other factors: inertia, market, who are the key players, and I think, to be honest, data is the biggest issue. A lot of times, for a lot of these problems, if we have the data, we can do many things today.
Got it. Got it. You know what? So, Professor Ahmed, now I will ask maybe a little bit of egoistic question, because now you're sharing a lot of information with us, like, you know, a lot of engineers around the world. But we were very fortunate to talk with, thought leaders like yourself a few months or years back. It depends, right? And thanks to, thought leaders like you, we were able to shape what we're doing and what we're building and focus on the right problems and the right use cases. So, back then you shared with us a lot of information, and thanks to you, Leo, is what it is right now. I would love to hear from you what you think, what you like about Leo that differentiate it from different ones, or what the greatest value that you see for mechanical engineers, and specifically what we showed and shared about Leo.
Sure. Yeah, I think the way I think about it is, right now, one thing that Leo is doing really interesting is tying the CAD aspect to real kind of products. As in your assembly example that you were showing, basically you can search in the marketplace, right? And you can find real parts, and then you can integrate them directly into your workflow. And to a large extent, when we are thinking about AI, when I was showing you this chart of adoption and deployment challenges, a lot of time is spent in monotonous tasks, which are like, hey, I need to find this part, what fits in, and so on. And these are the places I do think there is, it needs to get fixed. Unfortunately, the current process is very painful to design products. And this is where I do see that a lot of what you're doing is very exciting.
I really appreciate that. And now, in a broader sense, because you are such a thought leader in our industry, you're being approached by a lot of, teams and groups that are building cutting edge AI technology. Some of them are partnering with you. So could you provide us like a quick overview on where like AI is excelling right now, and where is it even deeper gonna accelerate and excel?
So I think maybe I will break it down into a few parts. So one is there is the tech world, which is solving some problems, and then there is the engineering simulations world, and maybe the engineering CAD and so on, right? In the tech world, if you really look at the frontier models today, like ChatGPT Pro or like Grok or like Gemini latest models, the ones which are the highest end models, I don't think most people realize that capability front that is already there. Most people are using the free version, and though the capability difference between the free version and the top tier model is huge, and the top tier models already are extremely good. I mean, if the world freezes today and like AI progress and everyone just like stops doing what they're doing, you can spend the next 5 to 10 years just using those models for design automation. I mean, there is just so much that is already possible today. I'm just amazed at what we have already achieved with all the reasoning things. But that capability front is also improving. So that's very exciting. And I think there is a lot that our community can leverage and use and get out of it. Then there is also like some capability fronts that we are not even looking at a lot of times. So, for example, from Google DeepMind, they have looked at alpha geometry, which is a geometry problem, right? And it won at the Olympiad level. And they have also came up with Alpha Evolve, where they're basically training these models to create new programs to evolve into new things. And that, to me, is an exciting direction that will have huge implications for scientific discovery. Now, yeah, within simulations, I think there is a lot of interesting work around, like, good old automation, right? Like, can we actually GPU accelerate a lot of simulations? Can we actually predict them, bring in physics and so on? I mean, this is all good things. And eventually what this leads us to do is it helps us create better designs faster to a large extent, or to kind of like improve the cycle time.
Got it. So just before we're unfortunately the time is about to be up. So Professor Ahmed, assuming like I envision two people in front of us. There are about 100, but I envision two people. One resembles the engineering leaders, right? The decision makers. Those are the literally can decide if to leverage AI tomorrow for their organizations. And I see also like I feel affinity towards the early career, the junior mechanical engineers. Some of them are terrified that AI is gonna take their jobs. So just to wrap up, what is gonna be your recommendation for the first guy, for the leader? Maybe you'll tell them, I don't know, use AI tomorrow, check this and that or whatever. What's gonna be your best recommendation? And what's gonna be your best recommendation for potentially your students, the MEC students in your classrooms at MIT, at course 2?
Sounds good. Yeah, so I think for the first one, I would definitely say think a lot more about AI infrastructure, which includes like what is the data that you have? Is it in a format that it's the most boring thing most people don't want to invest in, but it's the most important thing to actually be able to use AI. Like the data is not well stored. It is in some kind of like server which is sitting on someone's computer somewhere. I think this is a big problem. So if anyone wants to get real value out of AI, I think a lot of times it is about like figuring out your data. Again, this is assuming that we are not just doing like large language model deployment, which already is happening. I think a lot of times people are just deploying and that will get us somewhere. So I'm not worried about that part. More of like, what is the unique aspect of that organization? What is the unique data? What is the knowledge of that organization? And I do think spending on that part is way more important than getting like a cool demo which will have a short shelf life. The second part for engineers, I'm not at all worried about jobs going out for mechanical engineers. Again, if you really understand like the capability front for the best AI for most engineering tasks right now is not there yet. The models are not proficient enough to kind of replace humans, but they are actually becoming sufficiently proficient that a capable human can become way more productive. So the question is, I think what we are thinking a lot about is how can we train our students to be more proficient in AI while being like strong in engineering fundamentals and really understanding the concepts, and what concepts do we need to teach now versus then the ones that we needed to teach earlier. And that is changing.
Got it.
This is like a much longer discussion than
and Professor Ahmed, thank you so much for your time and sharing with us a lot. I learned a lot. I'm sure that the guys here learned so much too, and there is a lot to talk about. A lot more to talk about and to learn from you. And would love to to have you in another time. I know that you're super busy, but if you're open to this, we would love to see you again. And thank you so much.
Great. Thanks for the invitation, and good to see the community. Thank you.
Absolutely. Thank you, Professor Ahmed. So just before we wrap up, we're 1 minute, after the deadline, and a lot of you gotta go to keep your day, right? It's just noon at the East Coast. So I want to add another remark. Us at Leo AI, specifically, I can talk only on our behalf. We're mechanical engineers ourselves. even in our long-term vision at Leo AI, we're not thinking about replacing mechanical engineers. The opposite. Our goal is to turn mechanical engineers into superhumans, right? To do things much better, to make decisions faster, choose parts faster, answer questions faster, get better access to their own data and to the knowledge that the organization already created, as well as the wealth of information that comes from the engineering industry. So rest assured, it's not, our goal is not to replace any one of you. I want to tell you guys that if you want to learn more about Leo and how Leo can help you, your specific needs, your specific team, I encourage you to fill out this, to choose a time to book a demo here on the link that I shared just right now on the Calendly. Just click on it and schedule a time. And please, it's very important, put your work email. If you're not putting work email, it's basically being automatically canceled. Not automatically, it's being canceled. Where Gmails or Hotmails, etc., are not acceptable there. Also, I encourage you to keep in touch with us, with the Leo AI team. If you have questions, if you want to share with us an idea of how we can make you more successful, get more business, be, more effective, more efficient, please reach out to me directly, and the team. So I'm writing here my email. I don't want, to have anything in the middle. So this is my email, maor@getleo.ai. Please feel free to inform me and the team. We would love to read all of your emails, all of your thoughts. Last but not least, I encourage you to join our MI community, the Mechanical Intelligence community. It's not associated with Leo AI only. It's powered by Leo AI. We fund it, but we give the room and the space for other AI startups, other AI companies, other groups, young, later career, everyone, to share their tools, share their questions and best practices. Because we really believe that the only ones that can know how AI is going to change our industry and how we work is not us, the founders. It's not us, the tool makers. It's you engineers. You are working today. You know what you need best than everyone else, regardless if we are from this university or this company. So please go there, share with us what you want to get, and we will do the best to provide it to you. We would never be able to do what we're doing without your insights and your support. So thank you so much for joining for the November webinar at Leo AI and the MI community. Thank you for the Leo AI team, the amazing mechanical engineers, AI researchers, developers, product managers that were here with us today and made Leo into reality and the MI community reality. Thank you, Moti Moravia and Nathan Steinberg, the amazing guys that answer your questions here. And I see that the Q&A panel is empty, so it means that they answered any of your questions. And I'm looking forward to see you in the next time in the December webinar. Stay tuned on the MI community, on the Reddit, Facebook group or LinkedIn group. We're going to inform you there when the registration is going to be ready. So thank you so much, guys. Had a pleasure and take care. See you next time, next month.